So today we're doing section 4.5, day 2, and I apologize about the audio. I'm actually doing a little bit of an experiment. I thought it was the condensing that was causing the audio and the video to be off, but to tell you the truth, I have a feeling it's my microphone. I just recorded this video and played it back and saw how much it was dragging before I condensed it. So I'm going to try this without the microphone, and then I'll see if I can look into it. So I apologize. We're going to go back to not necessarily having the best audio, but at least if it keeps time, that would be better than where we're at. So today we're talking about phase shifts, which are horizontal shifts and vertical shifts. Okay, so a phase shift is a horizontal shift. So you're going to know that a function has a phase shift because you're going to get this extra item in the parentheses. Think back just like when you had, y squared, f of x was equal to y to x squared, and then you had in parentheses x squared minus 1. Okay, so that's what it's going to look like today. It can also be the cosine function can have a phase shift. Alright, so let's talk about this. We know that the amplitude is the absolute value of A, whatever's in the front. We learned yesterday that the period was 2 pi divided by B. We know that the key points, or the little intervals, I call them key points. I don't know that anybody else calls them that. To find where your next key point would be, you're going to continuously add the period divided by 4 to wherever you left off at your last interval. Now, the phase shift. Now, this is important, is C over B. So really, you're taking the opposite sign of what you get here. Because remember, this would really be moving to the right because it's a negative. You think it should go left, but it goes right. Okay? So it has the opposite sign. And it is where the curve begins, or where the graph begins. So the first one I'm going to do with you, I'm going to walk you through, and you're not going to enjoy it, but we're going to talk a little bit about how we can try to do this without so much work, because mathematicians kind of lazy. Alright, so we're going to graph one period. So my function is 4 sine parentheses 2x minus 2 pi over 3. So my first question for you is, does it have a phase shift? Yes, it does, because in the parentheses I've got this extra constant tagging along. So could you please tell me the amplitude, the period, what your key point intervals would be? I probably need to come up with a better name for them. And your phase shift. Alright, so my amplitude is easy to find. The absolute value of the lead coefficient, I get 4. So that's the highest point this graph will go. The period, I take 2 pi divided by b, and b is what is behind the trig function, so it's 2 pi divided by 2, or pi. To get these intervals, I take the period and I divide it into 4 pieces. So I take pi and cut it into 4. Now my phase shift, this is negative, so I'm going to make it positive. You don't obviously need to write the positive. And I take C over B. So I'm going to do 2 pi over 3 over 2. So I have a compound fraction. If you remember to get rid of a compound fraction, I'm going to multiply by his reciprocal, both top and bottom. So this clears its way out, and I get 2 pi over 6, which is pi over 3. Okay, this is my starting point. Alright, so let's take all this and go ahead and fill in our chart. Okay, so here we go. I start out with some x. Way over here, I'm going to output some y. My function I'm plugging into is 4 sine 2x minus 2 pi over 3. I'm going to need 5 rows in my chart. And I'm actually leaving myself an obscene amount of room because it's not going to be anything you guys are going to want to do repeatedly. So we're going to have to find a better way to handle this. So do you agree that pi over 3 is my beginning number? Alright? Now, my interval, my key points were at pi over 4. So I take my beginning point, pi over 3, and I add pi over 4. So first I want to go ahead and just fill in our x values. Alright? I would recommend you grab your calculator. Most of you can't stand fractions, so let's go ahead and use the tool we have. 1/3 plus 1/4 gives me 7/12. Now, do you have to use the calculator? Certainly not. You could get a common denominator of 12 and go that way. Alright, let me unzoom just a smidge. Alright, take your last stopping point, 7 pi over 12, and add your key point again, pi over 4. Now, notice my calculator already has 7/12 in it. I just have to add 1/4. And I get 5 pi over 6. Alright, do it again. Take your stopping point, add your key point. And I get 13 pi over 12. Last one. Take your stopping point, add your key point. And I get 4 pi over 3. Now, here's the part you're not going to like. The good news is we're going to try to figure out a way to survive without this middle part. Okay? Alright, here we go. You're going to go to this function and plug in your x values. So the first time through, it's 4 sine 2 times pi over 3 minus 2 pi over 3. So all I did was plug that in for x. Now I'm going to clean this up. So 4 sine, do you agree that this is 2 pi over 3 minus 2 pi over 3? So I get 4 times the sine of 0. Well, what is the sine of 0? On your handy-dandy sheet, we know that the sine of 0 is 0. So 4 times 0 is 0. Phew! That was a ton of work for one line. And we're supposed to do it 5 times? Holy cow! This is craziness. I'm going to walk you through it one more, and then I'm going to see if maybe you come up with a pattern. We talked about it in class today. Let's see if you remember. So 4 times the sine of 2. This time my input is 7 pi over 12. Minus 2 pi over 3. Alright, so it's 4 sine. This is going to give me 14/12, which do you agree is 7 pi over 6 minus 2 pi over 3, which right now looks like nothing, correct? So if I grab my calculator and I do 7, 6 minus 2/3, I really get a half. So this is 4 times the sine of pi over 2. We'll go back to your unit circle. Do you agree the sine of pi over 2 is 1? So I get 4. Well, now that's interesting because isn't that my amplitude? And didn't we talk about in class that sine starts at 0, goes to the amplitude, goes back to 0, goes to the opposite amplitude, back to 0. Now, if you want, we could continue to justify in the chart. I don't think any of us wants to do that. So from now on, all I need to see is the x, the input, and the output. Alright, we ready to graph this puppy then? Alright, so my amplitude is 4. I begin at pi over 3. And I go to 7 pi over 12, 5 pi over 6, 13 pi over 12, 4 pi over 3. And now I just fill in. When I start at pi over 3, I'm at 0. I go up to 4, back to 0, to negative 4, back to 0. And there's my sine curve. Alright, let's see if we can do a cosine without needing to fill out this chart. Alright, so number 2. Let's do y is equal to 1/2 cosine of 4x plus pi. So I need an amplitude, period, key points, phase shift. So first question again, do I have a phase shift? Yes, I do, because in the parentheses I've got this extra constant tagging along, so I do have a phase shift. Alright, let's go through our little pieces parts. The amplitude is the absolute value 1/2, which is 1/2. The period is 2 pi divided by b, and what is b in this case? 4. So do you agree that my period is pi over 2? The key point, take your period, divide it into 4 pieces. So pi over 2 divided by 4. Well, now that's a mess, but do you agree I can multiply by his reciprocal? These go away, and I get pi over 8. And finally, the phase shift. Be careful, it's c over b, but remember the sign changes. So now I'm positive I'm really going to be negative pi over 4. So that's my starting point, is at negative pi over 4. Alright, we ready to try the chart with just the x and the y this time? So I'm starting at negative pi over 4, and I need 5 lines. Okay, to this negative pi over 4, I'm going to add in my key point interval, pi over 8. If you need to, grab your calculators if you want to do it by getting a common denominator of 8, that works too. Alright, so negative 1/4 plus 1/8, I get negative 1/8. So negative pi over 8. To get your next row, you take your ending point and I add a key point. So negative pi over 8 plus pi over 8 is 0. Do the next row. Take your end point, add, so 0 plus pi over 8 is pi over 8, and then see if you can get the last one. Take my end point, add a pi over 8. If you need to, grab your calculators. These already have a common denominator, so you might be good. Were you able to get pi over 4? So if I don't want that middle column, I need to think to myself, what does cosine start at? Does it start at 0 or does it start at the amplitude? And I remember that cosine starts at the amplitude. So I'm going to start my graph at 1/2. Then I go back to 0, to the opposite of the amplitude, back to 0, back to the amplitude. See how easy that is without that chart? Now all I'm going to do is graph it. So I'm going to start off at negative pi over 4, negative pi over 8, 0, pi over 8, pi over 4. So I start at negative pi over 4, I'm going to half, back to 0, down to negative 1/2, back to 0, and up. And I always like to extend my cosine curves just because I like to see that really that sine curve, it was just a shift. But that's up to you. Really all I need is from here to here. Okay? Alright, so we've done 2 phase shifts. I'd like to end with a vertical shift. So how do I know that this has a vertical shift? I'm hoping you said because there was a +1 tagging along, which means that it's going to shift up 1. Alright, let's go through and define everything. I need an amplitude, a period, key point, phase shift, vertical shift. Alright, look what you got. Your amplitude should be the absolute value of -2, which is 2. My period is 2 pi divided by b, and b is whatever behind the cosine, which in this case is a 1. So this has the normal period of 2 pi. My key point, take your period and cut it into 4 slices. So I get pi over 2. Is there a phase shift? Do you have anything in parentheses with your x? No. So you have no phase shift. Do you have a vertical shift? Yes, you do. Up 1. Now there's really 2 ways to do this, the lazy way and the detailed way. I'm going to opt for the lazy way. So the lazy way says graph just that function and then do the shifting at the end. Alright, that's the way I'm going to do it. So I need my x and my y. So again, where does this one start if we have no phase shift? If we have no phase shift, we start at 0. Now I'm going to add my key point interval to each of those. Alright? So I take 0 plus pi over 2 and I get pi over 2. Take my last stopping point, add a key point. And this is going to be your normal one that you're used to. So 3 pi over 2 and 2 pi. Now, cosine. Cosine begins at the amplitude, but be careful. This time I'm going to go down to -2 to 0, +2, 0, -2. The reason it does that is because it's -2, so it's flipping over the x-axis. Alright, so here's -2, here's 2. Let's see, we've got pi over 2, pi, 3 pi over 2, 2 pi. Okay, I'm beginning at -2, back to 0, up to 2, back to 0, back to -2. So that's my parent. Now don't be careful, you're not done. That is just this function. Now I need you to shift it up 1. So if you're going to take the lazy way, you got to remember that now you got to go up 1. So take every point and go up 1. And there's my new graph. Alright, so you guys have a great evening. I will see you tomorrow.